The elements in group 1, which is found on the left-hand side of the periodic table, are called alkali metals. They have one electron in their outer shell, and the electron is usually given away in a chemical reaction. So the first alkali metal we're going to look at is lithium. Now lithium's got the electron structure 2,1. And what that means is it's got 2 electrons in its first electron shell and 1 electron in its next electron shell. It's the least reactive of the alkali metals, and it burns with a red flame when it reacts with oxygen. And lithium floats on the surface of water, and there are bubbles seen, which is hydrogen gas being given off, and we call that effervescence. The next alkali metal we're going to look at is sodium. Now sodium's got the electron structure 2,8,1. Now that means that it's got 2 electrons in its first orbital, 8 electrons in the next orbital, and 1 electron in the outer orbital. It's more reactive than lithium because the outer electron is less strongly attracted to the positively charged nucleus, and this is because it's further away from the positively charged atom's nucleus. So that electron's further away, so it's easier to lose. The metal floats on the surface of water, which releases enough heat that the sodium actually melts, and the sodium moves quickly across the surface of the water as it melts. Now, when you burn sodium, it burns with a yellowy orange flame and can react with when it reacts with oxygen. The last one we're going to look at is potassium. So potassium, another alkali metal, has the electron structure 2,8,8,1. See if you can remember what that means, the electron structure 2,8,8,1. It's more reactive than lithium and sodium also because the outer electron is least strongly attracted to the nucleus. So it's further away, it's easier to lose, therefore it's more reactive. The metal floats on the surface of water as with the other two, and has a similar but more vigorous reaction compared to sodium. And when you burn it, its reaction with oxygen creates a lilac flame. Lilac's like a purpley colour. So just to recap some of that, which alkali metal is not very reactive, burns with a red flame in oxygen, and has the electron structure 2,1? Well, that is lithium. And some of those reactions of alkali metals again with oxygen. So alkali metals are in group 1. You've got lithium, has the electron structure 2,1, that burns with a red flame. Sodium, electron structure 2,8,1, burns with an orange or yellow flame. And potassium, electron structure 2,8,8,1, burns with a lilac flame. So lithium is less reactive than sodium, if we remember. And all of the elements in group 1 have 1 electron in their outer shell. Now these metals are very reactive because they easily lose that 1 electron that is found in the outer shell, and they have similar properties and usually react in similar ways. So the first thing you need to know is that when they react with oxygen, they rapidly turn from a shiny silver colour to a dull metal oxide. So for example, potassium oxide is very dull in colour, but potassium is a shiny colour. Similarly with chlorine, so a metal chloride is formed if you react a group 1 metal with chlorine. For example, sodium chloride, which dissolves in water and gives a colourless solution. And if you react a group 1 metal with water, the metal will float on the surface and it will melt and create a metal hydroxide, for example, lithium hydroxide. When they react with water, the energy released is enough to melt the metal, so it will melt as it touches the water. And remember, just to recap those reactions, an alkali metals react with water, produces a metal hydroxide. With chlorine, it produces a metal chloride. And with oxygen, it produces a metal oxide. Now, alkali metals rapidly turn from silvery shiny colour to dull when they're exposed to oxygen. Now, as you move down group 1 of the periodic table, the reactions of alkali metals become quicker and more vigorous. This is because of a number of reasons. So first of all, the electron shells increase as you go down the group, meaning there's a greater distance between the outer electron and the nucleus, which makes it more reactive and therefore the reaction more vigorous. There's also the strength of the attraction to think about. So the greater the distance between the outer electron and the nucleus, the weaker the attraction is to them, and therefore the easier it is to lose. And the weaker attraction between the outer electron and the nucleus, the easier it is for that electron to be lost. So, just to recap again, what is formed when alkali metal reacts with water? Remember, that's a metal hydroxide. And the elements found in group 1, found on the left-hand side of the periodic table, are called alkali metals. What colour of solution is produced when metal chloride is dissolved in water? That is a colourless solution.